going on, guys? Welcome back to my channel, The Nature of Science. Guys, today we are going to discuss about the Antennae Galaxy and the Oort cloud. First topic is the Antennae Galaxy and the Oort cloud, and the second topic is gas and terrestrial planets. As you can see here. So first we are going to discuss about the Antennae Galaxy and the Oort cloud. Okay. Now basically, as the name suggests, Antennae Galaxy. Antennae Galaxy is a galaxy like our Milky Way galaxy, which has planets in it, right? Galaxy, what is a galaxy? Galaxy is something that has solar systems that is made up of dust and all, right? So let's talk about the fun facts of Antennae Galaxy. Spiral galaxies that combine as the antenna will end up as elliptical galaxies as usual. This kind of merger will remove all the traces of their spiral arms. Now what does this mean is that these are spiral galaxies, right? These are the spiral galaxies, and spiral galaxies have a black hole in the center as told by me. Now what basically is fun here, that many of these galaxies combine to form something like this. Okay, that's very bad. Wait, I'll show you a proper picture of it as well. It will form something like this. It will form something like an antenna. Okay, I know my drawing is very bad. Leave it. It will form something like antenna. Okay, now that galaxy is known as Antennae Galaxy, and also when these galaxies combine to form this antenna, they will end up as the elliptical galaxies. I know that you all know what are elliptical galaxies. Now this kind of merging will remove all the traces of their spiral arms. Her spiral galaxy has an arm like our Milky Way. It has arms like this, right? It has arms like this. Now when they merge together, the traces of their arms will be removed. Their arms will disappear. Now, first thing was this. Second thing, the closest colliding galaxies near the Milky Way galaxy are the Antennae Galaxies. Obviously, these galaxies are those that are like forming with the spiral galaxies. Now many of these galaxies are coming together, merging together to form this Antennae Galaxy. The new galaxies' globular clusters are the massive young star clusters formed during the starburst activity. Now the new galaxies that are forming have these globular clusters, right? They have the globular clusters and are the massive young star clusters which formed during the starburst activity. Starburst, when a star bursts. Fourth, at least one point of interaction when the Milky Way and the Andromeda galaxies combine, they will look similar to the antenna. Now you know these two galaxy names, Milky Way, in which we live in the Orion arm, and second one, which is the Andromeda galaxy, and that Andromeda galaxy is the galaxy which is nearest to the Milky Way galaxy, right? So now next comes, out of the millions of new stars created during the antenna merger. Now out of the when this merging happened, millions of stars were created during the antenna merger. Only about 10% of them will live longer than 10 million years, or else that's because they'll be massive super blue giants, a type of a star that will quickly consumes its nuclear fuel and explodes as a supernova. Now, I already told you what is a supernova. Now, these supernova are the stars that burst out and send us a very big solar blast, and their light and radiation is like 1,000 or a lakh times, bigger than the you know bigger than the sun. So they'll explode as a supernova because they'll become super giants. Now that is super giants. Blue super giants are basically those massive stars that will be quickly consume its nuclear force, nuclear fuel, you can say, and explode. It will be over. The entire Oort cloud is divided into two parts. Okay. Now, divided into two parts. The outer part is known as the spherical shaped, and the inner part is the donut shaped. Bahar wala part is the what do you say? Spiral shaped, spherical shaped, and the inner part, you have seen a donut, right? Now, inner part is the donut shape. Now comes what actually is it. See, now I'm gonna show you 1 second. Let me bring that book. I'll just come in a second, okay? Yup. So I bought that book and I opened that page now. So as you can see here, first of all, let me show you this. This is the antenna galaxy I was talking about. See, it forms an antenna. It forms an antenna over here. It starts from here and ends up on here. It's like an antenna, okay? Okay. Now I was talking about this. As you can see this thing right here. I hope you can see it. This page, this one. Now this here is the Oort cloud. All of this gases here are the Oort cloud. Kuiper belt is inside here, and the Kuiper belt, you know what is the Kuiper belt? Kuiper belt is marking the end of our solar system. Now Kuiper belt is here and the sun is there. Oort cloud is basically surrounding whole of the solar system of ours. Okay, and also this is the Antennae Galaxy again. Here, it forms the antenna. Yes. So now we are gonna talk about this Oort cloud. Now let me tell you this one thing, that the planetoid Sedna, discovered in 2003, is thought to be a member of the inner Oort cloud. Now I told you just now what is the inner Oort cloud and the outer Oort cloud. We just discovered a planetoid in 2003, which name is Sedna, and it is thought to be a member of the inner Oort cloud, which is donut shaped. Yes. Oort cloud objects are also known as the trans-Neptunian objects. Okay, let me tell you what is this. Now the Oort cloud objects, the objects in the Oort cloud are also known as the trans-Neptunian objects. I repeat, trans-Neptunian objects. I'll show the spelling by writing it on the board. It's, wait a second, trans-Neptunian. It's trans-Neptunian. I'll tell the spelling: TRANSNEPTUNIAN. Trans-Neptunian. It is believed that the sun may have captured the Oort cloud cometary material, forming the outer disk of the other stars that were forming in the same nebula as us. Now it is believed that the sun may have captured the Oort cloud cometary, means the debris and the small rocks and the dust material from the outer disks that form the outer disk of other stars that were forming in the same nebula as ours. Our solar system is surrounded by a thick bubble of icy debris is supposed to be the Oort cloud. As I said right now that the Oort cloud is basically nothing but a thick bubble, right? A cometary nuclei that contains ice dating back to the origin of the solar system is the Oort cloud. Now we are going to discuss about the gas and terrestrial planets. Jupiter, Saturn, Uranus and Neptune are known as the gas and ice gas giants. Let me tell you now. Gas giants are also known as the Jovian planets. Jovian planets. Jovian, Jovian planets. The planets that take longer to orbit around the sun because of their great distances are the gas giants and or the ice giants planets. The farther away they are, the more time they take to make one trip around the sun. Now because like Mercury takes the shortest time, you can imagine, because it's nearest to the sun. Now it's like if this is the sun, I'll show you. If this is the sun, the marker is the sun. Now this is Mercury. It's so much here. It will take this much time. But then the other planets, that is, I told you the second rule which made by the NASA Astronomical Union was that any planet will be considered a planet if it fulfills a demand that it will not go in any other's orbit. So as you can see now, the Venus will revolve more farther because it should not go in the orbit of Mercury. Okay, then comes our Earth. Earth will go more far because it should not enter Venus, and like that it will go till Neptune. Now Pluto is not considered as a planet now, so please don't consider that Pluto is a planet, and also don't say that there are 9 planets in the solar system. In 2006 it was considered as a dwarf planet. Okay, so the Calper mission has found that gas giants around more than 1,000 stars. These large exoplanets are often referred to as hot Jupiters, super Jupiters, and the giant Neptunes. Now these are some names to the exoplanets that are the planets outside the solar system. An icy layer over its solid rock core and covered with a gaseous atmosphere is Uranus. Uranus has an icy ground, rock core, and covered with gaseous atmosphere on it. Neptune has a water ammonia ocean for a mantle overlying its rocky core. On its rocky core there is a ocean, that is the ammonia ocean, and it for a mantle. Okay, in the terrestrial worlds of the solar system, the densities of the gas giants are much lesser than the densities of the rock, because as you know that the density of air is much lower than the rock. The gas giants cores of the gas are crushed under tremendously high pressures, and they are very hot, up to 20,000 Kelvin, while the cores of the ice giants Uranus Neptune are 5,000 Kelvin and 5,400 Kelvins respectively. That's it for today. We have some facts left for gas and terrestrial planets that we'll discuss in the next video. Thank you guys for watching. Please like, share and subscribe. Thank you. See you.